Networking is the part of AWS that scares almost everyone. VPCs, subnets, route tables, gateways, two kinds of firewalls. It sounds like a lot. But here's the secret. It's just a private network, built from a handful of simple pieces, and each one has a job you can picture. Over the next few minutes, we'll build a complete network from scratch, one piece at a time, using the same running example, a photo app called Photo App. By the end, the whole thing will finally click. It all starts with a VPC, a virtual private cloud. Think of it as your own private, fenced-off plot of land inside Amazon's cloud. Inside it, you're in control, nothing gets in and nothing gets out unless you explicitly allow it. Two important things to know. First, a VPC lives in one region, say in Virginia, but it stretches across all the availability zones in that region. And second, every account comes with a default VPC to get you started, but for anything real, you'll create your own. Everything else we build today lives inside this one VPC. When you create a VPC, the first thing you choose is its address range, written in something called CIDR notation. For example, 10.0.0.0/16. That /16 is the important part. It means the first 16 bits are fixed, leaving the rest free, which works out to about 65,000 private addresses to hand out. A bigger number after the slash means a smaller range. /24, for instance, is just 24, for instance, is just 256 addresses. You pick a range big enough for everything you'll ever put in here, because you can't easily shrink it later. Let's make that concrete. Say your VPC is 10.0/16. You don't put servers directly in it, you carve it into smaller blocks, one per subnet. So you might cut out 10.0.1.0/24 for a public subnet, and 10.0.2.0/24 for a private one, each holding 256 addresses. One quick gotcha, AWS quietly reserves the first 4 and the last one in every subnet, so you actually get 251 usable. Plan your ranges so they never overlap. Those smaller blocks are your subnets, the rooms inside your VPC, and subnets come in 2 flavors. A public subnet has a path to the intranet, so it's where things that must be reachable live, like a web server or a load balancer. A private subnet has no direct route to the intranet at all, so it's where you hide your sensitive stuff, above all, your database. This public versus private split is the single most important habit in AWS networking. The golden rule, your database goes in a private subnet, never a public one. If you remember nothing else, remember that. Now, one subnet isn't enough, because a subnet lives in a single availability zone, a single physical building. If that building has a problem, everything in that subnet goes with it. So the pattern is, create the same kind of subnet in 2 or 3 availability zones in Virginia, that's us, East 1A, 1B, and 1C, and run a copy of your app in each. Now, if an entire data center goes dark, your users barely notice, because the other zones keep serving. That's how you go from a hobby project to something that actually stays up. So far, our VPC is sealed. Nothing can reach the internet. To open a door, you attach an NAT Gateway. It's a single component that bolts onto your VPC and becomes its one front door to the public internet. Public subnets send and receive traffic through it. A couple of things to remember. There's just one NAT Gateway per VPC, and simply having it isn't enough. A subnet only becomes truly public when its traffic is actually pointed at that gateway, which brings us to the piece that does the pointed at that gateway. Route tables. This is the piece people skip, and then nothing works. A route table is just a list of rules that says, for this destination, send traffic here. Every subnet is associated with one. The magic trick is simple. A subnet is public only because its route table sends internet-bound traffic, that's 0.0.0.0/0/0, meaning everywhere, to the internet gateway. A private subnet's route table does not have that line, so its traffic has nowhere public to go. Same servers, same subnets. The only real difference between public and private is one line in a route table. Now let's lock it down, starting at the server. Around each individual server sits a security group, its own personal firewall. By default, it blocks everything, and you open only what you need, maybe port 443 for HTTPS from anywhere, or port 22 for SSH, but only from your office's address. 2 things make security groups easy to live with. They're stateful. If you allow a request in, the reply is automatically allowed back out, no extra rule needed. And you can reference one security group from another, so you can say only my web servers may talk to my database without ever hard-coding an IP. There's a second, coarser firewall that works one level up at the edge of an entire subnet. It's called a network ACL, where a security group guards one server. A NACL guards every server in the subnet at once, like a checkpoint at the gate of the whole compound. But it behaves differently in 2 ways. It's stateless, it has no memory of a request, so you must write rules for both the inbound and the outbound direction yourself. And its rules are numbered and evaluated in order, with the ability to explicitly deny, which a security group can't do. So, when do you use which? Here's the simple mental model. The security group is your everyday tool. It wraps each server, it's stateful, and it can only allow. The NACL is a blunt instrument that wraps a whole subnet, is stateless, and can explicitly deny. In practice, 90% of your work is just security groups. You reach for NACLs when you need a broad, subnet-wide rule like blocking a known bad range of addresses from an entire tier. Think of them as two layers of defense, the gate of the compound and the lock on each door. But wait, we put our database and app servers in a private subnet with no route to the internet. So how do they download security updates or call an external API? You don't make them public, that would defeat the point. Instead, you use a NAT Gateway. You place it in a public subnet and you point the private subnet's route table at it. Now, private servers can reach OT to the internet through the NAT for patches, updates, outbound calls, while the internet still can't start a connection IN. It's a one-way valve, outbound can IN. It's a one-way valve, outbound yes, inbound no. One more piece, because real apps run more than one server. You put a load balancer out front. It gives you a single address for users to hit, and it spreads their requests evenly across all your servers, across multiple availability zones. It also does health checks if a server stops responding. The load balancer quietly stops sending it traffic and routes around it, so your users never see the failure. So the public thing users actually connect to usually isn't a server at all, it's the load balancer. Now let's watch a single request travel through everything we built. A user opens Photo app. Their request hits the load balancer in the public subnet, reachable because the route table points to the internet gateway. The load balancer picks a healthy web server and forwards the request. The server's security group allowed port 443, so it's let in. The web server needs data, so it calls the database in the private subnet, allowed only because the database's security group trusts the web tier. The database's security group trusts the web tier, so it's unreachable from the internet. The answer flows back out the same way. Every hop guarded. That is a VPC. Let's put the whole picture together one last time. You start with a VPC and give it an address range with CIDR. You carve that into public and private subnets, spread across availability zones for safety. An internet gateway is the door, and route tables decide who actually uses it. Security groups guard each server and NACLs guard each subnet. A NAT gateway gives private servers a safe way out, and a load balancer shares traffic across them. 9 pieces, and now you know what every single one does. And that is AWS networking demystified. Not magic, not memorization, just a private network built from pieces that each make sense. If the VPC finally clicks for you now, do me a favor and subscribe to Viaan Cloud, because that's exactly what this channel does. Take the scary parts of AWS and make them simple, with pictures. Tell me in the comments which topic you want broken down next. I'll see you in the next one.